got some understanding of how the X-rays are produced and those X-rays photons are produced, we're going to look into why the images look a little different, and it's relating to two things really, or one thing mostly, which is hardness. So hardness of the X-rays. So we're going to be describing the X-rays themselves now. So first of all, hardness is a measure of how penetrating the X-ray is. So when I showed you the X-ray of the hand image, mostly we can see bone and not very much of the soft tissues. That wouldn't be very good if we wanted to X-ray and see a kidney, for example, because kidney is soft tissue and it wouldn't show up at all. So hardness is a kind of a measure of that, how penetrating that they are. So with the hand, no flesh, we just saw bone. That must have been quite hard X-rays. Not so hard they penetrate the bone absorbs them, but the rest of the soft tissue in the hand does not. So it's a measure of how penetrating an X-ray is. The greater the hardness is, the greater the penetration, and the more likely that you'll just see bone. Now we're going to talk about another thing which is intensity. So intensity is a measure of, just a measure of the amount of power the X-rays are supplying per unit of area. Now this is a bit of a grey area now, because if I were to have lots of very hard X-rays going through an area, then I don't necessarily need there to be a lot of photons, but generally we would say that intensity, if I kept the hardness the same, I would increase the intensity by increasing the number of photons. So there's a couple of ways that I can talk about intensity. By definition, it's the measure of power that the X-rays are supplying per unit area. They supply it in two ways. They can do it with the pure number of photons, but they can also have less photons but with more energy. So higher frequency, lower wavelength photons. Okay, so X-rays, like all of the EM spectrum, is a range of frequencies, a range of wavelengths, and there are harder ones and softer ones. And when we talk about intensity, usually people are really talking about the number of photons rather than the hardness of the photons delivering that power. But we'll see, so I'll talk about it in that sense as we go along. So we're going to look at how we increase hardness now, or change hardness, and how we increase intensity. So, if I want to increase the hardness of these X-rays producing, then I need a bigger energy change. So, if I want these photons to have more energy, then I need them to have been moving faster so that they decelerate a lot quicker as well. So, if they are moving quicker, then when they are slowed down by this tungsten, then the energy that will be converted will be a higher energy. And we know from E equals HF, that means the frequency will be higher of those photons, and those higher frequency photons are the ones that are more penetrating. As we know, gamma rays, for example, penetrate through quite a lot, but X-rays are absorbed by bone. We now realise they're absorbed by bone, whereas a gamma ray will pass all the way through bone no problem, because they're higher frequency. So we are producing higher frequency by increasing that speed of the electron. And how do we do that? Well, we have to increase the potential difference to the anode and make a bigger difference, because if this voltage is higher, this potential difference is higher, that will increase the speed of those electrons, and that goes by the energy being little e for the charge on the electron multiplied by that accelerating voltage, capital V. So that will increase that value a lot more, and that value will be converted directly as an energy change from electrical energy, EV, into kinetic energy, a half mv squared. Since the mass of the electron is remaining the same, the speed of the electron will be greater, and that means the acceleration or deceleration of the electron when it hits this tungsten will be more. The Bremsstrahlung radiation will be more, the braking radiation will be more. That means that the photons will be more penetrating. So that's how I change the hardness. I change this voltage. If I have a lower voltage, I will have less penetrating, softer photons. If I want them to be harder, then I will need to increase them. Sometimes I will want softer ones. If I want to X-ray a kidney, then I need them to not be quite so penetrating. And so I'll change the hardness. When it comes to intensity, as a rule, we are talking about having more electrons being moved across here, because more electrons means more photons. More intense rays might be useful in that we might like to form that image quite quickly. After all, the more exposure that you have, the more likely you are to have those ionising energies from the X-rays cause some kind of mutation or lead to bad things, which isn't usually as bad for a patient as it might be for the radiographer if they didn't look after themselves and make sure they're shielded. So a more intense image, a more intense ray, not image, a more intense ray is produced probably by producing more electrons, and that will be about turning the potential difference on this up. So literally more electrons are boiled off and are then accelerated over here. So the more electrons there are here, the more photons there are per second. That means a higher intensity of ray, and I can perhaps make that image a little faster, and maybe I'm looking after my patient a little bit more when I do that.